Algebra 2, operations with radical expressions. Here we go. First slide. Summarize these four as best as possible. This is basically what you're going to live by for this section, okay? These four rules here. And it's honestly really only three. The first one's not really relevant. The index n is as small as possible. That's almost going to be the case. That's always going to be the case pretty much anyhow. That one's not really going to change, like happen for you guys. So you really don't have to worry about the first one. The second one, the long one, we're going to come back to that one because it takes the most explaining. Third one, the radicand contains no fractions. Anybody remember what the radicand is?
Oh yeah, I remember.
Javon.
It's what we square root.
Good. It's what you're square rooting, it's what you're cube rooting, it's what's inside the radical. Okay, the radicand is what is inside the radical. So inside the radical, you cannot have any fractions. Okay, the radicand contains no fractions. The second one, or the fourth one rather, says that no radicals appear in the denominator. Okay, the denominator of fraction, it cannot have any radicals. Those two go hand in hand. Those two we'll talk about tomorrow. Okay, those two we'll talk about tomorrow. Today we're focused on basically number 2. Okay, basically number 2. It's a long-worded definition as far as the actual rule. The rule states the radicand contains no factors other than 1 that are nth powers of an integer or polynomial. It's a lot of big words. Yeah. Okay. The radicand contains no factors other than 1 that are nth powers of an integer or a polynomial. If only you guys had someone here that could really make that make sense.
We do. You, right?
Oh, is that why they pay me?
It's not you.
No, I guess I'll take a stab at it. Let's try this. Okay. Let's take, for example, the square root of 48. Okay, so this is explained in number 2 here. And when we take 48, I'm going to factor tree it a specific way to make my point on this example. I'm going to go 2 and 24, and I'm going to go 2 and 12. It's a square root, so I'm looking for pairs. Here's my pair, and I'm going to go 2 square root of 12. And I'm going to, is that correct? Cody says no. Why not, Cody?
Because you can keep going with 12.
That's exactly what this rule says. Okay, that's what this rule says. If you can factor it, you got to factor it. That's what that means. Okay? No factors other than 1 that are nth powers. Nth powers in this case would be second powers. There's something in here that's a second power of something that's 4, right? 2 squared. Okay? So that rule basically says if you can factor tree it more, you have to. Okay, so this one goes 3 and 4, 2 and 2 to actually give you a final answer of 4. We're at 3. Okay? That's what that rule means. If you can factor tree something out of a radicand, you have to factor tree it out of a radicand, more or less. Okay? How'd I do? Pretty good?
Yes.
Sweet. I'll ask for a pay raise. Okay? I'll take you guys as letters of references too. I would like a pay raise. These 14 people would vouch. I'd love to see it on my paycheck. Okay? Everybody good here? Okay, let's go next. We got a couple examples here. I think we got 4 to do today. All right? Sorry. Try to get a back rest. Okay, number 1, square root of 32x to the 8th. How are we going to start this problem? What do you want to do? Factor tree what? 32. Factor tree 32. Good. However you want to factor tree 32 is up to you. I'm going to go 2 and 16. 16 is going to go 4 and 4. There's my pair of 4s, and my 2 that stays in. So 4 and square root of 2. From the old days, right? And if the question was square root of 32, that would be our answer, but we also have as x to the 8th inside. So how do we take care of that? Divide 8 by 2. Remember, divide the power by the index. Index, if it's not there, is 2. 8 divided by 2 gives you 4. Good. So x to the 4th out here, and there you go. So see, yesterday, remember how I said everything yesterday was going to work out perfect? And then yesterday I said today that changes today? Here that changed. Okay? Not perfect no more. So we got the 4th root of 16, a to the 24th, b to the 13th. All right. What's our index this time? 4. Good. Okay, pay attention to that. So we need groups of 4 this go around. So factor tree 16, that goes 4 and 4. Each 4 goes 2 and 2. You need groups of 4. There's one big group of 4 in your 2s. Okay, so we got a 2. Take care of the number first. Go to the others after that. All right, now, remember your trick here is to divide the exponent by the index. Okay, so let's do that. 8 to the 24th divided by 4. 24 divided by 4 gives you 6. So we got 2, 8 to the 6th. And then let's do b. b to the 13, 4th root. 13 divided by 4 is? Save that. Hang tight with that. Miss Peterson? 3.25. Now, wouldn't life just be grand if we could just go b 3.25 and call it good, right? Wouldn't that be something? Yeah, it would be something, but we can't do that. Sorry. Okay. Remember what you're doing. How many b's do we have? We have 13 b's. Now, I don't suggest this way because eventually I'm going to get to, like, big numbers. Okay? So you're not going to, want to write out 77 B's. So you're going to have to learn the shortcut. Otherwise, your paper's going to be nothing full of A's and B's, and you're going to be, way behind. Okay? We're looking for groups of 4, right? Okay, so here's a group of 4. Here's a group of 4. Here's a group of 4. How many groups is that? That's 3 groups of B's. How many are left over? 1. Now, Yasser answered the question when I said, what's 13 divided by 4? The actual best way possible for this question. Okay? He said 13, remainder 1. Or 3. Did I say 13? Crap, and I put it on video. Oh my gosh, I'm going to sound like an idiot. 3, remainder 1. Okay? 3, remainder 1. The 3, because it divides it, how many? 3 times what? Starts with an E. Evenly. Okay, ain't got time to play Jeopardy today. Evenly. Okay, 4 divides 13 3 times evenly, right? And it has 1 left over. So that 1 stays inside. He doesn't have a partner to come out.
Oh.
Okay? Or does that make sense, everybody?
So if it was 2, it would just be B squared.
So if it, yeah. So say if this was B to the 14th, right? You'd still have 3 groups of B, so it'd still be B cubed on the outside, but you'd have 2 B's left over, so it'd be B squared inside. Because you have to have a group of 4 before they come out as 1.
That makes sense.
Okay? So however many times it divides it evenly is what goes out here. Whatever's left stays inside. Okay? I didn't circle it yet. Don't you take a picture yet. We ain't done.
I got it on here so I can see it.
Okay. Now, we're We're not quite done yet. We're missing one number. One thing. And it's super important. There's something missing in our answer that we need.
Is it the, it's not the index, is it?
Oh, yeah, it is.
It is?
Yep. You need the index.
Oh,
Okay?
is that required to?
Yes, it is. Okay? And we'll talk more about that tomorrow as far as why it is. But you need this index in your answers.
Oh, you don't have a class for
I'll talk to you on Friday about it. I might, Book, you know what? I might just come find you in the hallway and talk to you. I meant what I said. I'm just going to run you down and talk to you about it. Booker, here's why you need it! Okay? Booker's over here like, own little world. Okay? Yeah, we'll talk more about why you need that index tomorrow. Okay? Or Friday. Crap! Friday! All right?
You don't have a class Friday.
Yes, you do. Don't give me that crap.
Oh, twice, third.
Be that.
All right, there's your last two for the day.